We discussed question 11 for A-Level Mathematics 1, Paper 1, for May and June of the year 2020. You're given a diagram where the curve y equals to 8 over x plus 2 is shown, and you have a line 2x plus y intersecting the curve at 2 points, point A and point B. The point C lies on the curve, and the tangent to the curve at C is parallel to AB. So you have a tangent line here at point C that is parallel to AB. So AB is on the line with equation 2y plus x equals 8. And this equation can be rearranged. You see 2y plus x equals 8, then 2y is negative x plus 8, or we have y equals negative x over 2 plus 4. The slope of this line is negative 1 over 2. Then, since the tangent at C is parallel to this line, we can say that dy dx at the point C, at C here, this is equals to negative 1/2. The slope of the tangent is given by dy dx. This is what we get from the information given. Part A. Find by calculation the coordinates of A, B, and C. A and B are the points of intersection between the line and the curve. So what we could do is we could substitute the equation of the curve, which is 8 over x plus 2, into the equation of the line, 2y plus x equals 8. So you replace y with 8 over x plus 2, then we have 2 times 8 over x plus 2, that equals negative x plus 8, or 8 minus x here. We can move the x over. From here, we can see that 16 over x plus 2 is 8 minus x. Now we can cross multiply. We multiply throughout by x plus 2. Then you have 16 on the left, and you have 8 minus x, x plus 2 on the right. We can expand the right side to get 8x plus 16 minus x squared minus 2x. Collecting like terms, we have negative x squared plus 6x plus 16 equals 0. Sorry, not equals 0. So we have 16 equals negative x squared plus 6x plus 16. When you move the 16 over, you have 0 equals negative x squared plus 6x. Or we can just write this as x squared minus 6x equals 0. Factor out the x, and you have x minus 6 equals 0. Set each of them to 0, you have x equals 0, or x equals 6. For these 2 points here, A and B, either x is 0 or x is 6. When x is 0, we can replace x equals 0 into this equation of the line. 2y is 8, so that y is 4. Then point A has coordinates 0, 4. Point B should have an x coordinate of 6. So you substitute x equals 6 into the equation of the line 2y plus x equals 8. So that 2y plus 6 is 8. And we have 2y equals 2, y equals 1. from here we see that B here has coordinates 6 and 1. To find the coordinates of point C, we know that point C, at point C, the tangent is parallel to AB, so that the derivative dy dx at C is negative 1/2. Y is 8x plus 2 to the negative 1. We can find dy dx. So dy dx, you have 8, bring the negative 1 down. You have x plus 2, reduce the exponents by 1, and that is negative 2. So dy dx is negative 8 over x plus 2 squared. That gives you the value of dy dx. And we know that at point C, dy dx is negative 1/2, which is the slope of this line here passing through AB. So we set negative 8 over x plus 2 squared to negative 1 over 2. 2 negative will become a positive, so that 8 over x plus 2 squared is 1 over 2. Now we can cross multiply. When we cross multiply, we have 16 equals the square of x plus 2. We can write this as the square of x plus 2 equals 16. Taking square root on both sides, x plus 2 is plus minus square root of 16, or x plus 2 is plus minus 4. Then x is 4 minus 2, or negative 4 minus 2. We have x equals 2, or negative 6. Now that is not possible because on the diagram, clearly x must be positive. So x must equal 2. Now when x equals 2, we need to find the value of y. So we substitute x equals 2 to y equals 8 over x plus 2. Y now is 8 over 4, which is 2. Then point C has coordinates 2 and 2. Part B, we need to find the volume generated when this shaded region here that is bounded by the line and the curve is rotated 360 degrees about the x-axis. So we are going to rotate this region about the x-axis and you form a volume. So you form a solid and we need to find the volume of the solid. That area is bounded above by the line y equals negative 1/2 x plus 4. And it is bounded below by the curve y equals 8 over x plus 2. So when you are revolving this about the x-axis, then the volume of the solid generated, you have pi, and you integrate y1 squared minus y2 squared with respect to x. We found the coordinates of A just now to be 0, 4, and B here has coordinates 6 and 1. So when we revolve about the x-axis, you integrate with respect to x from x equals 0 until x equals 6. Then the limits of integration is 0 and 6. Now y1 would be the equation for the line. So y is 1/2 x plus 4. Then in that case, you integrate y1 squared. So we have negative 1/2 x plus 4. And we square this minus y2 squared. So y2 squared. Now y2 squared, you will have 64 over x plus 2 squared. And we integrate this with respect to x. When we integrate ax plus b to the n with respect to x, when n is not -1, we actually have the formula ax plus b to the n plus 1 over a times n plus 1, which is the new exponent plus the constant of integration. This a here is actually this a is the coefficient of x. So for the definite integral that we have -1 over 2x plus 4 to the 2. And this second term, we can write this in the form of 64, x plus 2 to the -2, and we integrate with respect to x. For the first term here, a is -1/2. Upon integration, you have -1 over 2x plus 4, increase the exponent by 1, divide by the new exponent, and multiply by the coefficient of x, which is -1/2. And then you have 64 here for the second term, and x plus 2. Increase the exponent by 1, that becomes -1. And you divide by the new exponent. The coefficient of x is 1, so you don't have to do anything. That is 0 to 6. Okay, let's see. For this case, the denominator is -3 over 2, and you have -1 over 2x plus 4 to the 3 in the numerator. The 2 negative becomes a positive, and we can now rewrite that x plus 2 to the -1 as x plus 2. Evaluate from 0 to 6. Okay, now let's look at this. Pi is here, and this is -3 over 2 in the denominator. We can write this as -2 over 3. It's in the denominator, you just flip the fraction. -1/2 x plus 4 to the 3, and the rest stays. Now to evaluate from 0 to 6, you replace x with 6, and then you subtract the same expression when x is replaced with 0. So you have -2 over 3, -1/2 x is replaced with 6 plus 4 to the 3 plus 64 over 6 plus 2. And now you subtract the entire expression when x is replaced with 0. So you have -2 over 3, -1/2, 0, plus 4 to the 3, plus 64 over 0 plus 2 is just a 2. So for this part here, that is -3 plus 4. So that would end up with, this part will give you -3 plus 4, which is 1. So you have -2 over 3. 1 to the 3 is 1. We don't bother writing. And 64 over 8, that is an 8. So after that, for this part, you have 4 to the 3. So 4 to the 3 will give you 64. Then what you have here is -2 times 64 over 3. So -128 over 3. 64 divided by 2 is 32. -2 over 3 plus 8, the 2 negative becomes positive, 128 over 3 minus 32. And -2 over 3, so you have 126 over 3 minus 24. And that should give you 18 pi. So that has a cubic unit. That will give you the volume of the shaded region.